Everyone listening? Anytime we look at a coordinate or anything, we are going to end up on the Cartesian plane now. So in grade 10, you did trig, but it could be a triangle anywhere. Your guys this year is always going to be a triangle. You'll get a coordinate, and then it will be a triangle made with respect to the x-axis so that you can get a reference angle. Okay? Reference angles are the bow tie angles. So it comes from the center of the circle and then to the x-axis. Do you see that? Yeah? Even if it was here in quadrant 1, if you had a coordinate there and it was here, we would still go to the central axis and down. Do we agree? So in trigonometry in grade 10, we learned that the hypotenuse never changes. Yeah? It's the longest side. However, your opposite and your adjacent do change depending on which angle you're looking at. Kids who do not understand that concept fail trig miserably because they don't know which is the opposite of the adjacent. Okay? Now, in our trig, on the unit circle, your adjacent and opposite will always stay the same because we are always going to be looking with respect to the central angle. So the angle that we're looking with respect to is this one. Do you see that? Or this one. Yes? Okay. So this is my hypotenuse. Yes? This would be my hypotenuse. It's the longest side and it's across from the 90-degree angle. Okay? The opposite angle is, or the opposite side, sorry, is always across opposite to the angle. Yes? So if we're always using the central angle, this one will be opposite. This one will be opposite. Do we agree? I just put died as a pun. That would be a downfall. Yo.
So the adjacent is just always the one on the x-axis?
Yes. So our adjacent is the one that's beside that angle. Okay. So we're all listening because I want you to understand this. We're not drawing anything. We're just listening. We're making it all make sense. Yeah? So we know that sine theta, not sin. If it's sin equals, you are wrong. This says sine, if you put the angle beside it, is so. So it's opposite over hypotenuse. I'm just leading you into the actual notes. Okay? Cos is ka. So it's adjacent over hypotenuse. And toa is tan theta is opposite over adjacent. So we used to use opposite and adjacent and hypotenuse all the time because opposite and adjacent change. Correct? With respect to the unit circle, your opposite and your adjacent do not change. We agree? So your adjacent is always beside the angle. What value is that? X or Y? X. So this is X, this is X. So instead of adjacent, what could I put now? X value. So I could go like this. Correct? What is the opposite always? Y. Because it's where my Y value would be. Correct? It's the vertical value. So my opposites could all be Y's. And my hypotenuse is actually, if I kept going around like this, it's from center to edge. So it gets replaced with R for radius. So do you see how sine is actually Y over R? Cos is X over R. Tan is Y over X. That's why it is that way. Because you will always look at that central angle and your adjacent and opposite don't change if you're always looking at the central angle. Okay? So if we look at our actual notes here, it says sine is Y over R, cos is X over R, tan is Y over X. You don't really need to memorize them if you remember SOHCAHTOA because opposites are always replaced with Y's, adjacents are always replaced with X, hypotenuse with R. But way back in the day, some of my students decided to come up with acronyms to help themselves out. They're stupid, but they work. So, sign your resume. Sign and then Y over R. Sign your resume. And then they thought up, cook extra rice with an X. Yep. And then tan your Xbox because we don't want it to have a vitamin D deficiency. You're welcome. You might be like, these are stupid. You're going to be saying them in about a week. They'll be like, tan your Xbox. Oh, I love when people are like, sign your Xbox. I'm like, you're not signing your Xbox. You're signing your resume. So they make their own. So it has to be Y over R. Okay? If a point is on the unit circle, your radius is 1. So you don't have to find it. If a point is not on the unit circle, you'll have to find it. If a point is on the unit circle, you already have the cos trig ratio and the sine trig ratio. The cos trig ratio is the x value on the unit circle. The sine trig ratio is the y. Correct? Okay. Those are the primary trig ratios. We also have secondary trig ratios. Can you make sure your unit circle is out and your formula sheet, please? Go. My hair. Driving me nuts. Okay. Okay. So, just so you know, the secondary trig ratios are called reciprocal trig ratios. What does reciprocal mean? Not opposite. What does it mean? You flip. Reciprocal, guys listening, reciprocal means 1 over the fraction. 1 divided by any fraction is 1 times that fraction flipped. So reciprocal just means you flip it. You keep the same signs, you flip it. So cosecant goes with sine. And if you don't remember that, at the top of your formula sheet, it literally gives you this formula. It says cosecant theta equals 1 over sine. Well, let's think about it. So it would be 1 divided by sine. Sine is your resume, correct? So it'd be 1 divided by y over r, which is actually the same as 1 times r over y, which equals r over y. So because cosecant is the reciprocal trig identity to sine, it's 1 over sine, you just go, if it's sine your resume, it's cosecant is resume your. They flip. That's all that happens. They are called the secondary trig ratios or the reciprocal trig identity. Okay? Along with secant comes cos. So if cos is x over r, secant is r over x. And cotangent goes with tangent. So it's 1 over tan. And tan is y over x. So cotan is x over y. Yeah? So those need to be memorized. The y's and r's and x. But you can also use SOHCAHTOA to get it. The other thing, too, with them is that if you forget secant or cosecant or cotan go with those other ones, they're on your formula sheet. You should not get them mixed up. Some people think cosecant goes with cos. The way you can also remember it is cotan goes with tan because it has the word tangent in it, right? And c's don't go with c's. So sine goes with cosecant, cos goes with secant. It's not sine and secant, cos and cosecant. It's see with that. So cosecant starts with a c, it goes with sine. Secant starts with an s, it goes with cos. That's another way you can think about it. The c's don't go together. The s's don't go together. But you need to know that. You have a formula sheet in front of your face that literally tells you, so you should never get them wrong. Okay? CAS rule. So, some people start with the C here, CAS, and then it's a difference in quadrants, or you can say all students take calculus. All students take calculus also works, but then you can start in quadrant 1. Why does CAS work? Let's talk about it. So, people memorize CAS, but you know what I think of memorizing. Memorizing is great as a side tactic, but you should understand, then you can choose some memorizing tactics, like sign your resume. But you should know why it's y over r, not you just memorize it because I told you so. So, let's talk about this. If I have a point in quadrant 1, we said all 6 trig ratios are actually positive there. Last year we didn't have 6 trig ratios, so we just said all 3 primary trig ratios were positive there. But why? Okay, so if we have a coordinate here, this would be our triangle. We have a positive x value, we have a positive y value, and r, guys, is always positive because it's a radius, and radius is a scalar quantity. So it's positive at all times. It's a length of measure. Paying attention? Okay. So if I did sine, it's all based on their signs, the actual the coordinate signs. So sine is your resume. So it would be a positive y over a positive r. So sine would be positive, correct? If I did cos, it would be a positive x over a positive r. So cos would be positive. Secant would be r over x, still positive, right? So if your primary trig ratio is positive there, the secondary trig ratio will still be positive because you're just flipping the numbers. You're not flipping the sign. And then tan is y over x. Those are positive. Cotan is x over y. Those are positive. That's why everything is positive there. Okay? In this quadrant, it says sine is positive. Sine theta is positive. What's its bestie? Cosecant then should also be positive because whatever the heck sine is flipped. Correct? Let's talk about it. So x equals, or sorry, x is not equals. X is negative here. And we have a positive y, and we have a positive r. We agree? So sine is y divided by r. Oh, it's positive divided by positive, so sine is positive. Cosecant is positive r divided by y, still positive. Cos is negative x divided by r. Oh, that's negative. R divided by negative x is also negative, so secant would be as well. And tan is y divided by x. Positive y divided by negative x, it's negative. Cotan would be negative x divided by y, which is negative. It's because of the coordinates in those quadrants being negative or positive. So this one sine is, this one tan is positive. So then its bestie cotan would also be positive. Well, y is negative here, x is negative here, r is positive, correct? Tan is y divided by x. Negative y divided by negative x. What happens when you divide two negatives? You get a positive. Negative x divided by negative y, you get a positive. If I do sine, it's negative y divided by r. That's a negative. Cosecant is positive r divided by negative y. And if I did cos, it would be negative x divided by r, which is negative. So it's because you're dividing different values. Some are positive, some are negative, correct? And then in this one, cos is the only one that's positive, and its best friend secant. And why would that be? Because x is positive and r is positive. But my y is negative, so anything involving a y is going to come out negative. Tans involve y's, sines involve y's, their flips involve y's, right? But cos is x divided by r, positive x divided by positive r, so it's positive. Secant is positive r divided by positive x, so it's positive. Yeah? So they gave you an acronym. All students take calculus or CAST. Start not in quadrant 1 and do CAST. I don't personally like CAST because it makes people forget what quadrant is 1, 2, 3, 4. But if you do all students take calculus, it follows the same quadrants as 1, 2, 3, 4. It's a C. Okay? All right. But that is why CAST works. Okay. Now, listening. If your radius is 1, what do we know about the coordinate? If the radius is 1, it's on the unit circle. So if the radius is 1, it's on the unit circle. Then we know we immediately have cos theta and we have sine theta. We have the trig ratios, right? X is cos, y is sine. Flip those and you have secant and cosecant. We agree? If it's not on the unit circle, our r will not come out as a 1. It'll be outside the unit circle or inside the unit circle. And then we actually have to use SOHCAHTOA, or the sine y over r part, to actually get the trig ratios. So if it's on the unit circle, it's actually easier, because cos and sine just come right off there. The trig ratios are sitting there in front of your face. Okay. So when I have a coordinate, the first thing I should always do is label it. So what we're going to do here is it asks us to, given the following point on the terminal arm of some rotational angle, find the exact value of the 6 trig ratios. So we're finding the exact value. Then it wants us to get the rotational angle, but I'm not dealing with that today. We're just getting the 6 trig ratios. So we label it, and then we plot it. So I have -2 and 1, 2, 3, 4, 5, 6. So my coordinates here. I always draw it with a central angle. Pretend that's a straight line. And then do I draw it towards the x-axis, because that's where reference angles are, or do I draw it towards the y-axis that is stupid and it looks like an hourglass and we never do that? Should I draw it to the x-axis, which is where the reference angles are, or to the y-axis that's stupid and we never draw it there? Oh my gosh. X-axis. You're not. Wow, that is not a straight line. Anyways, actually it is a straight line. It's just angled. Okay, so we always draw it towards the x-axis. We always draw bow tie figures, right? That would be a bow tie figure. We never draw hourglasses. We always draw bow ties. So let's label what we do know. We know x equals -2. We know y equals -6. So I can find tan right away, because tan is tan your x box. It's y over x, correct? So let's do that one first. Tan theta. Do not forget the theta beside your trig ratio. If not, it's just the word tan. Go to a tanning bed. I let you tan outside. That is what you have. You do not have the tangent. Okay? So you need tangent theta equals, and it's y over x. Because it's tan your x box. So we get tangent theta equals what over what, guys? Negative 6 over negative 2. Which actually equals positive 3. What is positive in this quadrant? All students take. So what's positive here? Tan theta is positive, and what else is positive? Cotangent. So far so good. It's looking like it's coming out, right? Cotangent is x over y. Instead of tan your x box, it's x box your. Cotangent is negative 2 over negative 6, which reduces to a third. So I can either show all the math to get a third, or I could say tan is 3 over 1, so cotan is 1 over 3. It's the reciprocal trig identity of it, right? So it just flips. And it flips because it was y over x, and now it's x over y. Okay, then I want to do sine. Sine theta. Sine your resume. Okay, your negative 6. Resume. We don't have the R. What the heck? How do I get an R? Go back to grade 10. Smart kid. We're going to do Pythagorean theorem. We're going to solve for R. So we're going to go negative 2 squared, x squared plus y squared equals r squared. Negative 6 squared equals r squared. 4 plus 36 equals r squared. R squared equals 40. Now when you physically use your arm and take the square root, what do you have to remember to do? Plus or minus. So we're going to get r squared equals positive or negative root 40. What did I tell you about r though? Yeah, always positive because it's a radian. It's a scalar measure. So it's going to be r equals root 40. Then we got to go back to grade 10 where we learned to write entire and mixed radicals. If I want to write this as a mixed radical, I want to reduce it. Root 40, what can I break it down into? One perfect square and one not perfect square. 4 and 10. So I can go square root 4 times 10. When the square root of 4 comes out, what is it? A 2. Now I loved when I used to teach grade 10 back in NOM. I swear it's been that long. People would go 8 and 5. And I'd be like, wow, those are two really nice numbers. And they do make 40. But they are completely useless in reducing this radical. Because remember, when you want to reduce a radical, you need a perfect square and something else. Because the perfect square comes out. So square root of 4 is 2. Great, awesome. 8 and 5 are two lovely, really awesome numbers, useless in reducing. Because 8 isn't a perfect square, and 5 isn't a perfect square. So people, or they would go 20 and 2. Like, also really nice numbers, neither of which are perfect squares. Okay? So we always have to find our biggest perfect square. So that 4 comes out as a 2, and we get 2 root 10. So I know my r equals 2 root 10, and it has to be positive. Okay. So sign your resume, 2 root 10. Now, guys, I always have to rationalize my denominator. So I need to get that radical to go away. Now listen, in grade 11, you guys learned how to rationalize a denominator. That was a monomial. And you learned to rationalize a denominator that was a binomial. So if you had like root 2 plus root 3, you multiplied by the conjugate. You went root 2 minus root 3. It canceled your middle terms off, and you had no radicals left. Okay? When it was a monom, you learned to throw yourself a party because life is easier. So I want the root 10 to go away. A lot of people will multiply by 2 root 10. You don't have to multiply by the 2. If you do, however, that's fine. It'll join the top and the bottom. You're just going to have to divide the 2 back out to reduce the radical. So, your choices. But when it's a monomial, we only have to multiply by the actual radical. So I can multiply by root 10. The reason why that is, you should always ask why if you don't know why, if you just memorize. If your reasoning is, my teacher told me if I multiply 2 radicals together, I get that number. That's not a reason. That is a memorization tactic. Why? Why is the reason. You should say why. Well, why that happens is when you multiply 2 radicals together, you multiply the number in front by the number in front, the number underneath by the number underneath. Proper terminology, you multiply coefficient times coefficient, radicand times radicand, correct? So if I multiply 2 together that are the same, let's talk about this. If I go root 10 times root 10, my coefficients are both 1. So I get 1 times 1, which is 1. And then I would get 10 times 10, which is 100. What is the square root of 100? 10. Now, let's expand this. Pencils down. I just want to say to you, what if it was cubed? We aren't going to get a cube. But if you understand a cube, then a square totally makes sense. Remember, you want to know why you do stuff. So when you're stuck, you just are mathing. You're mathing because you understand math. You're not trying to be like, oh, crap, do I multiply by the... I don't remember. If you don't remember, you never understood. You just memorized something. So say instead, this is just a side note. You're not writing this anywhere, please. If I had root 10, or cube root of 10, and I just multiplied by another cube root of 10, I would get cube root of 100, which is not a thing. So squared I can, because it's root 10 times root 10, which is root 100, and I get a squared. So what would I actually have to do here to get rid of a cube root? You'd multiply by cube root 10, and then do it again. Because now I'm going to have a 10. Remember the cube root? Remember this? You were taught this in grade 10. Remember when you have a square root, it's like a 2-for-1 special. So you have to take 2 of the same number out to get the number out. If it was a cube root, it's a 3-for-1 special. So you have to get 3 of the same number to be able to pull one out, correct? So in order for this to work out, I'm going to have to technically have cube root of 10 times 10 times 10, which would result in just 10. Yeah? Make sense? That's why you do what you do. If ever you're doing something just because that's what I was told, always ask why. Because there is a why behind mathematics. All right. So we go back here. We multiply by root 10. We get negative 6 root 10. Do not freeze on me. Thank you, boy. And then we get 2 times root 10 times root 10. Shh. Root 10 times root 10 is root 100, which is 10. Is everyone paying attention? So I'm going to get negative 6 root 10 over 20. Am I done? I have to reduce coefficients. So I'm going to get negative 3 root 10 over 10. Now, some people say to me, okay, well, if sine is that, cosecant is taking that answer and flipping it. That would work, but now I'm going to have to rationalize again. What would be faster? Just doing it right from what the acronym is. So this way I would have to flip it and then rationalize. If I just do cosecant theta, sine is y over r, cosecant is r over y. So I'm going to get 2 root 10 over negative 6. Then I just reduce it. So I get negative root 10 over 3. So you could take the answer, flip it, and then rationalize it, and then reduce it. It would take you a lot more steps. Or you can just take the reciprocal, which is r over y. Now, understanding, again, okay? Paying attention? I'll come back. Negative root 10 over 3. We agree? That's what the answer was. Everyone agrees? But they don't give the sign there. They give the sign here. Oh, wait. They don't give the sign there. They give the sign here. I get a whole bunch of you going, oh crap, I don't know. Let's use our brain cells and mathematics, right? I know it's a crazy concept. Let's understand. So fractions are just division, yes? Like a half is 1 divided by 2. 3/4 is 3 divided by 4. That's what it is. It's a division. That is what a fraction is. And you know that because if you're putting it into your calculator without the fraction button, you're going 3 divided by 4 in brackets. You are doing division. Yeah? So is this a true statement, these three being all equivalent? Let's talk about it. If I take negative root 10 and I divide it by 3, I'm going to get a negative decimal. Yeah? If I take root 10 and I divide it by 3, am I going to get a different number or the same answer as a number? Like if I do negative root 10 divided by 3, or root 10 divided by negative 3, I'm still going to get the same decimal, correct? And a negative in the numerator or a negative in the denominator makes a negative answer. True? The same negative decimal you would get. This one, if I take root 10 divided by root 3, I would get the same decimal, yes? And then I'm timesing it by negative 1. So I would get a negative decimal, right? So are they all the same? Yes. Just mathematically they're the same. So I get a whole bunch of people like, I don't know if I can move the negatives to the bottom. Am I allowed to move the negatives to the bottom? And like, would it result in the same decimal number with the same sign? And they're like, yeah. I'm like, then is it equal? They're like, is this a trick question? I'm like, no. They're like, yeah. I'm like, then you're fine. I'm saying this equals this equals this. That's true. They equal, right? Yes. Yay. So they could give this answer, that one, or that one. They're all the same answer. So then I get the rocket scientists in my class who's always like, what if they put all three as a multiple choice answer? Could they? They're all right. No. They can't. They could put 1 and then 3 not like that.
Well, you could do all, like 1 A, B, C, and then all of the above.
Oh, Lord. You could. We don't do all the above. Yeah. Someone asked me how early it is. Very, it's hard. All right.
Please.
Not at this moment. Maybe for next time. Okay. So cos theta equals cook extra rice. Shh. So cos theta would equal negative 2 over 2 root 10. If I want, before I rationalize it, I can actually reduce it. So I go negative 1 over root 10, and then I rationalize. Negative root 10 over 10. And then secant, if cos is extra rice, then secant is rice extra, because they flip. So it's going to be 2 root 10 over negative 2. These cancel. And I get root 10 over negative 1, which is not incorrect, but I promise you that is never going to be a multiple choice solution. How are they going to write it? Root 10 over negative 1. Negative root 10. Because root 10 divided by negative 1 would just change the sign of the root 10. Okay, you're going to flip over and try the next two. Go. They're nicer than this one because you don't have to rationalize. So when we plot this one, we have an x and a y. Shh. We have 3 and negative 4. Draw a bow tie. X equals 3. Y equals negative 4. Quiet, please. Shh. R equals 5 by doing Pythagorean theorem. You're going to find out if you get a 3, 4 as your x and y, you're going to be excited because it ends up as an r being a nice number, not like root 40 was. Okay? So these are a lot faster. So sine theta is y over r. To be honest, the only thing that should be positive in all your trig ratios is cos theta should be positive, guys. And secant theta should be positive because they're friends. So sine is sine your resume. So I get sine theta equals negative 4 over 5. Cosecant theta is resume your. So it's going to be the flip of that. Negative 5 over 4. Cos theta is cook extra rice, so it's going to be 3 over 5. secant theta, its bestie is going to be 5 over 3. Tangent theta. Now check and make sure that you actually have thetas beside all of your words, or you are wrong. Go check. Because I'll have a whole bunch of people going sin, cos, tan, no thetas beside. Tan is tan your x box, so it's negative 4 over 3. And cotan is that flipped, so it's negative 3 over 4. 3 tells you it's on the unit circle. But if you didn't know it was on the unit circle, you would go to plot it. It'd be like here. And you'd have x equals negative 12 over 13. Y equals 5 over 13. And when you do Pythagorean theorem, you get r equals 1. So you could show it with this. You could go sine theta equals, sign your resume, 5 over 13, which is y over 1. Correct? But that's just 5 over 13. Remember I told you if the coordinate isn't on the unit circle, you have to do the trig ratios to find it out. If it is on the unit circle, this is cos theta. This is sine theta. Correct? If it's on the unit circle, because you're just dividing by a 1. Yes? And dividing by a 1, what does it do? Nothing. So we have sine theta is 5 over 13. We have cos theta is negative 12 over 13. And then we have their reciprocal trig identities really easy because it's just those flipped. So sine goes with cosecant. And instead of 5 over 13, it's 13 over 5. And cos goes with secant. Instead of negative 12 over 13, it's negative 13 over 12. Tangent, you can either look at it as tan your x box, y over x, or you can look at the formula sheet where it says sine over cos. Either way, you're going to get 5 over 13 divided by negative 12 over 13. The cool thing about stacking fractions is if something can cancel in both numerators, you cross it off. If something can cancel in both denominators, you cross it off. So these 13s can cancel. So my answer is negative 5 over 12. If that makes absolutely no sense to you, you can write them sideways. You could go 5 over 13 divided by negative 12 over 13. When you divide, you flip the second half and multiply, invert and multiply. So we get 5 over 3 5 over 13 times 13 over negative 12. Then these cancel and I get negative 5 over 12. Exact same answer. Which one is better? The one you get right, use it. That is the better one. I do not care which version you use of the crossing the denominators and numerators or the multiplying and flipping. And then cotan is easy because it's the flip of that. For your homework, in section 4.3, you can do 1 and 2. That's it. Numbers 1 and 2 in the 4.3 homework. That's it. Okay? Remember, your homework is due Wednesday. If you wait till the very end,